In this lecture, we're going to complete our discussion about economic decision criteria. In particular, we're going to talk about two criteria. We're going to talk about the benefit-cost ratio and the payback period. Let's talk about the benefit-cost ratio first. We said every economic decision criterion has two components. It has a measure of worth and a decision rule. The measure of worth for the benefit-cost ratio is simply the ratio of the prospective benefits divided by the prospective costs, where again the interest rate I is the minimum attractive rate of return, and the period of time to which we calculate the prospective benefits or the prospective costs, capital T, is typically either 0 or the planning horizon N, meaning the benefit-cost ratio is nothing more than the present worth of the benefit cash flows divided by the present worth of the cost cash flows, or it is the future worth of the benefit cash flows divided by the future worth of the cost cash flows. When we introduced the decision criterion, prospective benefit and prospective cost, we demonstrated that it made good economic sense to accept when the prospective benefit exceeded the prospective costs. Therefore, the decision rule for the benefit-cost ratio is we will accept an opportunity J whenever its benefit-cost ratio is greater than 1. Otherwise, we'll reject. Let's take an example. Let's assume we're faced with a choice between two alternatives, alternative A1 and alternative A2. A1 calls for an investment of $2,000 for which we receive the benefits of $900 each year for 5 years. Alternative A2 calls for an investment of $3,000 for which we'll receive benefits of $1,200 each year for 5 years. We can solve this problem using any of the decision criteria we've talked about. We could use prospective benefit and prospective cost. We could use future worth or present worth or annual worth or internal rate of return, but let's solve it using the benefit-cost ratio and present worth. If I calculate the benefit-cost ratio on alternative A1, it's 1.71. Specifically, if I find the present worth of these benefit cash flows as of time 0 and divide by the prospective cost, which is $2,000, the ratio is 1.71. Alternatively, the benefit cost ratio for alternative A2 is 1.52. Specifically, that's the present worth of these benefit cash flows as of time 0 divided by the prospective cost of $3,000 results in 1.52. I can also calculate the present worth for each of these alternatives, and they are shown here. Now, some individuals would look at this series of calculations and be in a bit of a quandary, because for them it appears to suggest that perhaps the benefit-cost ratio criterion and the present worth criterion are suggesting alternative choices. Specifically, it would appear to them that the present worth of A1 is greater than 0, meaning that cash flow stream is an economical course of action. The present worth of alternative A2 is greater than 0, meaning that this is an economical course of action. That the present worth of A2 is greater than the present worth of A1 suggests they should choose alternative A2. On the other hand, they might look at the benefit-cost ratios and notice the benefit-cost ratio for A1 is greater than 1, suggesting it is an economical course of action. The benefit-cost ratio for A2 is greater than 1, suggesting it is an economical course of action. And that the benefit-cost ratio for A1 is greater than the benefit-cost ratio for A2, suggesting to them that perhaps they should select alternative A1. In other words, it would appear that the benefit cost ratio criterion seems to suggest choose A1, whereas the present worth criterion seems to suggest choose A2. The problem here is a need to do a proper incremental analysis. If we take the differences between alternative A2 and alternative A1, you end up with this incremental cash flow stream. An incremental investment of $1,000 for which we will receive incremental benefits of $300 each year for the next 5 years. Then let's calculate our benefit cost ratio and our present worth. The benefit cost ratio for the incremental cash flow stream is 1.137, which is greater than 1, which says that incremental cash flow stream is an economical course of action. The present worth is 137, which is greater than 0, which also says this is an economical course of action. In other words, by doing a proper incremental analysis, both the benefit cost ratio and the present worth decision criterion lead you to the same decision. The problem here is benefit cost ratios, like internal rate of return, are not additive. That is, the benefit cost ratio does not have an equivalent decision rule. In using the benefit cost ratio decision criterion, one must explicitly do an incremental analysis. For the present worth criterion, future worth, annual worth, those have equivalent decision rules, and one can make the choice based simply on the present worth of the individual cash flow streams. But if you use the benefit cost ratio as your decision criterion, one must explicitly calculate the incremental cash flows and calculate the incremental benefit cost ratio to reach a proper decision. Let's now talk about the second criterion, payback period. This is a popular secondary criterion, and by secondary I mean this one is often used in conjunction with the other criteria that we've talked about up to this point in the course. It has a measure of worth and a decision rule. You'll notice that I've put quotation marks around the word worth. This particular criterion is more a measure of liquidity than it is necessarily of worth. What this criterion is designed to do is to help one evaluate and determine that point in time at which one just earns back one's initial investment. For example, if you were to invest $10,000 in some investment opportunity, this criterion is designed to help identify that point in time in which, when you get back revenues on this investment, that you will have just earned back your initial $10,000. The idea is basically this, that if you make an investment, your funds are now at risk. If the investment does not go well, you could lose your initial investment. This criterion is designed to help identify that point in time at which you would have just gotten back your original investment, meaning those funds are no longer at risk. And everything you receive from that point in time into the future basically is just profit over and above your initial investment. A formal definition for the measure of worth is this. It is that point in time wherein the net cash flow stream from time zero to that point in time just equals zero. The interest rate often used in this calculation takes on one of two values. It is either the minimum attractive rate of return, or sometimes the interest rate is simply zero, in which case this is often called the undiscounted payback period. There is a decision rule, and we will accept an investment opportunity J when its payback period is less than a pre-specified maximum payback period. Otherwise, we will reject. In the case when we have multiple alternatives, the manner in which this criterion is often used is to prefer that course of action which has the shortest payback period. This particular criterion will not necessarily lead you to the same decision as the other economic decision criteria that we've talked about in this class. I'll show you why in just a moment. Let's take an example. Let's assume we have an opportunity A1. It calls for an investment of $9,760 for which we will receive revenues of $5,000 each year for the next 5 years. I'd like to make a decision as to the economic attractiveness of that opportunity. I can use any of the decision criteria we've talked about. Here I've shown two. I've calculated its internal rate of return. The internal rate of return on this opportunity is 43% per year. I've also calculated its present worth at the minimum attractive rate of return of 25%. It's positive. It's $3,686. This is an economical course of action. That is, investing $9,760 to produce that revenue stream over the next 5 years is profitable. Let's use payback period. What I'd like to know is how long does it take for me to get back my original investment of $9,760 with interest. My initial investment is $9,760. When I compound that forward at the minimum attractive rate of return of 25%, that will grow to $12,200. This $12,200 can be thought of as an opportunity cost, meaning if I were to not invest in this cash flow stream and invest it at the minimum attractive rate of return, the amount of funds that I would have given up is $12,200. By investing in this cash flow stream, however, I'm going to get back in the first year $5,000. So the amount that remains invested or at risk of my initial investment is $7,200. That $7,200 will grow at 25% to $9,000. At that point in time, I receive another $5,000 out of my investment such that the amount that remains invested of my initial investment is $4,000. That grows at 25% such that the amount that is invested as of time 3 is $5,000, and then at that point I receive another $5,000, in which case the amount of capital that remains invested is 0. The payback period on this opportunity is 3 years. If the maximum payback period that I'm willing to accept is greater than 3 years, say 4 years or 5 years, then I would accept. On the other hand, if the maximum payback period I'm willing to accept is less than 3 years, say 2 years, then I would reject. Notice, depending upon what my maximum payback period is, I may accept or reject this opportunity and make a decision different than the other two decision criteria. Payback period is not based on the same sort of calculations that the internal rate of return and the present worth are based. Specifically, payback period only takes into account those cash flows up to the point of the payback period. It did not, in this case, take into account the cash flow at time 4 or the cash flow at time 5, which the internal rate of return and the present worth do take into account. That's the reason that payback period may not necessarily lead you to the same decision as the other criteria. All of the other criteria take into account all of the economic consequences of the decision. Payback period only takes into account those cash flows up to the point of the payback period. Let's take another example. Let's assume we have an opportunity in which we can invest $10,000, for which we'll receive revenues of $4,600 each year for the next 5 years. Let's calculate its payback period. Well, I begin with an initial investment of $10,000. Assuming that I'm going to have a minimum attractive rate of return of 25% per year, as I had in the previous problem, that will grow to $12,500. At that point, I liquidate $4,600 from the investment such that the amount that remains invested is $7,900. That grows at 25% to $9,875. I then liquidate another $4,600 such that the amount that remains invested is $5,275. That grows at 25% to $6,594. I liquidate another $4,600 such that the amount that remains invested as of time 3 is $1,994. That grows at 25% to $2,493. I then liquidate another $4,600, and the amount of capital that remains is a positive $2,108. The payback period for this problem is somewhere between 3 years and 4 years. You'll notice by the 3rd year, we had not yet quite gotten back all of our initial investment. By the 4th year, we had gotten it back and then some. In this particular problem, if these cash flows represent accurately the amount and timing of the cash flows for this particular opportunity, meaning that we expect those cash flows to be discrete amounts occurring at the end of each point in time, then the payback period for this problem is 4 years. Why? Because at the 3rd year we hadn't quite gotten everything back. We actually had to wait till the 4th year to get it all back. On the other hand, if these cash flows are really an approximation, meaning perhaps we envision these cash flows of $4,600 representing perhaps the revenue from the sale of a new product, in which we're going to be receiving that revenue every day, each day for the next 365 days, and we have simply chosen to approximate that particular problem by representing it as a discrete amount, then in reality we probably would have had a payback period somewhat short of 4 years, maybe 3.6 or 3.7. Again, whether we accept or reject this opportunity depends on what the maximum payback period is that we're willing to accept. If the maximum payback period we're willing to accept is greater than 4 years, then this would be an economical course of action. If the maximum payback period we're willing to accept is less than 4 years, then it would not be an economical course of action. Let's summarize our lectures on economic decision criteria. That is, let's go back over the past several lectures and summarize all of the criteria that we've talked about. In the first lecture, we introduced the fundamental concepts of making an economic decision. We emphasized 2 aspects. We emphasized that in making decisions between alternatives, that these alternatives should be based on the differences. We then showed how in making that decision based on the differences is really a choice between the benefit series and a cost series. And we developed a decision criterion called prospective benefit and prospective cost. And we demonstrated that it made good economic sense that if the prospective benefits exceeded the prospective costs, it was an economical course of action. From that point, we then introduced some classic decision criteria. In particular, we introduced 5. Fundamentally, they are all reaching the same decision of a choice between benefits and a choice between the costs. They're just doing so in a little different fashion. The next lecture, we then introduced future worth present worth, and annual worth. They're simply ways to express the economic merit or worth of an opportunity by expressing it as a singular future amount or a singular present amount or as a uniform stream over a period of time. We demonstrated that for these particular criteria that each of them had an equivalent decision rule, meaning choosing the bigger number when faced with a series of alternatives and provided you had no capital rationing would lead you to a correct choice because they are additive. In our next lecture, we talked about the internal rate of return. We said this is probably the most popular decision criterion that you'll see in practice, and it's probably also the one that's the most misunderstood. We went through a series of exercises and examples dealing with the internal rate of return. We pointed out that this particular criterion, unlike all of the other criteria, has two decision rules. That is, one must know whether you're dealing with an investment opportunity or a borrowing opportunity to use the internal rate of return. One need not necessarily know that for the other criteria. We also pointed out that there are situations where, in fact, the internal rate of return can fail. That is, there are situations in which an opportunity may end up being a mixed investment borrowing. In that particular case, you cannot use internal rate of return. You'll have to turn to one of the other criteria to reach a decision. And then we just talked about the benefit-cost ratio. And basically, we just brought you full circle back to the prospective benefit and prospective cost. And all we did here in the benefit-cost ratio, rather than take simply the differences, we can do it by taking a ratio. And then finally, we talked about a popular secondary criteria. And again, by secondary, we mean this one is often used in conjunction with these other classic economic decision criteria. This particular one will not necessarily lead you to the same decision as these criteria, because this particular decision criterion does not necessarily take into account all of the cash flow consequences associated with the alternative. It only takes into account those cash flows up to the payback period. We will be using these economic decision criteria throughout the remainder of the course. What we'll be doing now is introducing some additional kinds of complications and considerations that one needs to take into account in doing an engineering economy study. But despite all of these complications and additional aspects that we'll be talking about, we have covered the fundamentals behind making an economic decision.